Welcome to science class, and now we are going to talk about the chapter motion. So let's see what are the topics to be covered. First, we will be describing motion and its types, then measuring the rate of motion, then the rate of change of velocity, then we will do graphical representation of motion, then we will talk about the velocity time graphs, equations of motion by graphical method, and finally we will talk about uniform circular motion. So let's start off with our first topic, describing motion. Now before we talk about motion, let's talk about reference point, like which point is taken as the reference, and then talk about it, right? So what do you mean by a reference point? Whenever you measure suppose you measure time, or you measure distance, or whatever you do, whatever you measure, you take some standard value or some standard points, right? Like for measuring with a scale, what you do, you take the initial point as 0, right? You take 0 as the reference, and according to that 0 point you move on to 1 centimeter, 2 centimeter, 3 centimeter, and so on. That means we take the initial point as the reference point, and according to that point we go on measuring the values accordingly, right? Now for example, suppose your school is 1 kilometer away from your house, but it may be 2 kilometers away from your friend's house, right? That means if your house is taken as the reference, your school may be 1 kilometer away from it, but if your friend's house is taken as the reference or the 0 point, your school will measure 2 kilometer away from the reference point, right? So that is exactly the meaning of reference, or taking a point as 0, and according to that point you go on measuring values all around it, right? So you can see here distances measured from each of these location or the references is different, right? If you change the point of reference, your measurement may change based on the location of the reference, right? If your location is far off or your reference point is far off, then your measured distance will be very large, and it is always taken as an it is always taken for granted that reference is always at the origin. Reference is always taken as the origin, or if you change your reference, that means you are changing the origin, you are shifting the origin to some other location, right? For the first case, the origin was your home, right? And you were measuring the distance of your school from your home, but in the next case the reference or the 0 point was shifted to your friend's house, right? So let's talk about motion now, and let us start with motion along a straight line. Now let us talk about motion on a number line. As you can see in here, actually if you walk along a road and if you mark certain points according to the reference level, if you take some point as the reference on the road and go on marking or labeling the road according to the distances you move, then it will exactly look as if you are walking on a number line, right? And this is what is shown in the figure. The numbers denote the distances from the reference in kilometers, right? 5 kilometer, 10 kilometer, 15 kilometer, and so on up to 60 kilometers. Now suppose an object travels in the given order from 0 to point A, and from point A to point B, and then from B to point C. Now if an object travels in this fashion, then the total distance traveled by it will be distance from O to A, which is 60 kilometers, right? and from A to B, which is 5, 10, 15, 20, 25, 60 plus 25 plus 5, 10, right? That means 60 plus 35, which is 95 kilometer, right? From 0 to A it is 60, from A to C it is 35. So the total distance covered by the object will be 95 kilometers. But if you talk about the shortest distance from its initial point to its final point, right? Initial point was O and the final point was C. So if you measure the shortest distance between initial point and the final point, it will be only 25 kilometer, right? After the complete motion, you will see that the object is only 25 kilometer far off from you, right? And this measurement, taking the shortest distance from the initial point to the final point, is called as displacement. Now just remember this, we will talk about it once more. The distance covered is the entire path covered by the object, but the displacement is the shortest distance between initial and the final point. Now, can displacement be equal to distance? Now let's talk about this. Let's break up the motion in three parts, from 0 to A, from A to B, and B to C. Now from A to B and B to C is the same kind of motion, so we can group them into one group and say the motion is from 0 to A and from A to C, right? Because A to B and then B to C will be ultimately A to C only. Now if we talk about the motion from 0 to A, the particle covers distance 60 kilometer, right? The particle covers an entire path of 60 kilometers, and here the shortest distance between the initial point and the final point is also 60 kilometers. Why? Because our initial point was 0 and now our final point is up to A, right? And the particle has not gone any further. But when the particle returns from A to C, he covers an extra distance of 35 kilometer, but the shortest distance between the initial point and the final point gets shorter. It becomes just 25 kilometers, right? So this is the concept of distance and displacement, right? Distance is the entire path covered by an object, but the displacement is the shortest distance between the initial point and the final point. Let's talk about uniform motion and non-uniform motion. Now I think from the name only you can guess what is uniform motion and non-uniform motion, but still let's look at it. When an object covers equal distances in equal time intervals, it is called uniform motion. Or a particle moves equal distances in equal time intervals, like in 5 seconds it covers 5 meters, and in next 5 seconds it covers 5 meter once again, and again in the next 5 seconds it covers 5 meter once again. So this is a kind of uniform motion. And here an example is also given: a car traveling at a constant speed of 20 kilometers per hour, right? 20 kilometers per hour, this is a constant speed. If a car can maintain this constant speed, we can say that the car is in uniform motion, because in 1 hour it is covering 20 kilometers. For every hour it will cover 20 kilometers only, right? So this kind of motion is called as uniform motion. No change in speed, right? No speeding up or no slowing down. And what is non-uniform motion? When an object covers unequal distances in equal intervals of time, like in first 5 seconds it covers 5 meters, in next 5 seconds it covers 2 meters, in next 5 seconds it covers 7 meters, and so on. Means the distances covered in equal time interval is not the same. and this kind of motion is termed as non-uniform motion, like a car in a crowded street. Now in a crowded street, what will happen? A car will first speed up, then apply its brakes, because some kind of traffic will be coming towards it, or some crowd will be coming towards it, right? Or some crowd will cross the road. So that is why a car has to stop quite often, and it allows the car to speed up sometimes and then slow down at the next time, right? First it speeds up, then it slows down, again it speeds up, again slows down. This is called non-uniform motion, right? Speeding up, slowing down continues, and speed is not uniform. Therefore we call this motion non-uniform motion. Okay, so let's talk about measuring the rate of motion. Now why do we need to measure the rate of motion? And the simplest answer is to measure how fast or slow an object is, right? If you want to know how fast it is or how much faster it is than the other objects, you need to measure the speed of each object, right? Either to compare it or either to know the actual speed, the exact speed. Now from your earlier classes, I think you know this formula: speed equals distance by time, right? Speed equals distance by time. This formula you know from your earlier classes. And one more thing, important thing, is average speed equals total distance divided by total time. Now here many of you might make mistakes. While different speeds are given, you might take the average of them to find the average speed, but this is not correct. Whenever speeds are given individually for different time intervals, you must find out the total time taken and also the total distance covered by the object, and then you must divide the total distance by total time. And this is how you should find the average speed, and not by simply taking the average of the speeds, because by doing that you will end up getting the wrong answer, right? So remember this formula: total distance divided by total time gives us the average speed, right? And here is an example of an average speed. A car travels a distance of 100 kilometers in 2 hours, and no other information is given about whether it speeded up sometimes, whether it slowed down sometimes, right? No other information is given here. So what we can tell: 100 kilometers divided by 2 hours, which is 100 kilometers divided by 2 hours, which is 50 kilometers per hour. This is the average speed of the car. Why? Because it might have speeded up for some time, it might have slowed down for some time, right? But on an average it has maintained the speed of 50 kilometers per hour. Why? Because it has covered 100 kilometers in 2 hours, right? Then you can see the car might not have traveled at 50 kilometers per hour all the time, right? So this is the concept of average speed. Average speed does not mean that the car has to maintain the same speed overall. It may speed up, it may slow down, but the total distance covered by it divided by total time will always be the same, will always be equal to the average speed. Okay, so let's do one example. An object travels 18 meters in 4 seconds and then another 18 meters in 2 seconds. What is the average speed of the object? Now if you try to do 18 divided by 4 and you get the speed, 18 by 2 you get one more speed, and then take the average, your answer will come out to be wrong. Now what you should do, you should first find out the total distance covered, which is 18 plus 18, right? It covers 36 meters, and in how much time? 4 seconds plus 2 seconds, which is 6 seconds, right? Total distance covered by total time, you will get 36 by 6, which ultimately ends up to 6 meters per second. This is the average speed. Now you can see that the object does not maintain the same speed always. at some point of time it is more than that speed, at some point of time it is less than that speed. So on an average it has covered 36 meters in 6 seconds, therefore its speed is 6 meters per second. Let's talk about speed along with direction associated to it. Now I think you know what it is called, right? Speed, we have the magnitude as well as the direction. Now speed is a scalar quantity. Why? Because it only has magnitude and no direction. But this quantity, as it has magnitude along with the direction, we can tell it that it is a vector quantity, right? And it is called velocity, right? Velocity is a vector quantity which has speed, the magnitude, and the direction along with it, like 4 km per second towards the north or 5 km per hour towards the east, right? I am telling a velocity. If I had told only 5 km per hour, it would have told only the speed of the object. But if we talk about the velocity, along with the speed we should mention the direction. And for speed, speed can change only when its magnitude can change, but velocity may change by the change in speed or change in direction or change in both of them, right? If you change the speed, velocity gets changed. If you change the direction, then also velocity gets changed. And we will apply this law somewhere else at the end of the topics, right? Just remember this: velocity gets changed when speed or the direction or both of them gets changed. Now, if the change of velocity during motion is uniform, or the rise in velocity or the fall in velocity is uniform, then we can talk about the average velocity. And how do we define average velocity? It is defined as initial velocity plus final velocity by 2, or just the arithmetic mean of initial and final velocity. You can see this formula is completely different from the formula for average speed. This is because it associates along with it direction, right? For average velocity, remember this formula: it is initial velocity plus final velocity divided by 2, or their arithmetic mean. And using symbols, we can represent this formula as V average equals U plus V by 2, and U is initial velocity and V is final velocity. U is initial velocity, V is final velocity. Okay, let's see one more formula for average velocity. Let's see one more formula for this. It is also total displacement divided by total time. For average speed, it was distance, right? Total distance divided by total time. But in case of average velocity, as it has direction with it, we consider total displacement divided by total time. Now, in case of distance and displacement, you have seen that for distance, every movement of the particle got added up, right? And for displacement, the particle moved forward, the displacement got added up, but when the particle moved backwards, the distance got subtracted, right? And that is why we ultimately get only the distance between initial and final point. This is how displacement is found out. And average velocity is found out in the same way. We consider the total displacement, taking all the kinds of motions. If it is forward, positive; if it is backward, negative, and we add them up to get the total displacement, and we divide it by the total time taken. We have seen two different formulas which actually apply to the same concept of average velocity, which is U plus V by 2, initial velocity plus final velocity by 2, and total displacement divided by total time. Let's use it for solving one question. Usha swims in a 90-meter pool. She covers 180 meters in 1 minute by swimming from one end to the other and back along the same straight line, same straight path. Find the average speed and the average velocity of Usha. Now, this question tests your concept of average speed and the average velocity, or speed along with its direction, right? Now let's see how to solve this. Let's consider case by case, right? So you can see the distance covered by Usha is 180 meters. Why? She went forward 90 meters and went back 90 meters and she covered 180 meters, right? And that too in 1 minute. But the displacement of Usha is 0. Why? She started from a point and went to the other side of the pool, and she came back following the same path to the initial point. So the distance, the shortest distance between her initial and the final point is 0. This is because her initial and final point are both the same. She had gone from the initial point and she had come back to the initial point itself. So distance is 180 meters, but displacement is 0 meters. Now the average speed is total distance covered by total time taken, which is 180 meters divided by 60, which is 3 meters per second. But what should be its average velocity? It should be total displacement by total time taken. So average velocity is nothing but 0 meters per second. Why? Because the displacement term is itself 0. So you can see, even if we cover a huge lot of path but ultimately come back to our initial point, our displacement will always be 0, and therefore the average velocity will always be 0. But our average speed will never be 0, right? Because we have covered a certain distance. Displacement might be 0, but distance will never be 0. Now let's check about the rate of change of velocity. Now you can see from this, if velocity gets changed, we are talking about non-uniform motion, right? In non-uniform motion, the velocity always gets changed. The speed gets changed or the direction gets changed. During non-uniform motion, velocity changes with time. The rate of change of velocity is called acceleration. You must remember this term, which is very useful. The rate of change of velocity is called acceleration. Now we can find out acceleration by the given formula: change in velocity divided by the time taken. The time taken to change this velocity. Like if I am speeding a car from 30 km per hour to 60 km per hour in suppose 5 minutes, so my acceleration will be the change in the velocity divided by the time taken for the change, which is 5 minutes, right? So by symbols we can write them as A for acceleration equals v minus u by t, or final velocity minus initial velocity divided by time. V is for final velocity, u is for initial velocity. So final velocity minus initial velocity divided by time will give us nothing but the acceleration. The acceleration is taken to be positive if it is in the direction of velocity, and negative when it is opposite to the direction of velocity. Like when I am speeding up or my velocity is going up, right, my final velocity will be more than my initial velocity, therefore my acceleration will be positive. But when I am slowing down the car, so my final velocity will be less than my initial velocity, and that is why I am slowing down. So if my final velocity is less than the initial velocity, I will always get a negative acceleration, right? So a positive acceleration means speeding up, negative acceleration means slowing down. And SI unit of acceleration is meter per second square. It is meters per second square. It should be plus here, right? So it is meters per second square. This is the unit of acceleration, SI unit of acceleration. SI unit of speed is meters per second. Similarly, SI unit of acceleration is speed divided by time, right? The unit comes from speed divided by time, or meters per second divided by second, which is meter per second square. This is the SI unit of acceleration. So let's do one example to check whether we can solve the question using the formula or not. Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Rahul pedals his bicycle to attain a velocity of 6 meters per second. He attains the velocity of 6 meters per second in 30 seconds. Then he applies brakes such that velocity of the bicycle comes down to 4 meters per second in the next 5 seconds. So in first 30 seconds he speeded up to 6 meters per second, and then in the next 5 seconds he slowed down to 4 meters per second. In the next 5 seconds he slowed down to 4 meters per second. Now we have to calculate the acceleration of the bicycle in both the cases. First case was speeding up and the next case will be slowing down. So let's take the question case by case once again. For the first case, cycle speeds up from rest, right? It was stated in the question the cycle started from a stationary position, or it was at a stop, right? It started from zero velocity or zero speed. It was at rest. At rest means the object is at zero velocity or zero speed. So for the first case we are taking it starts from zero speed and finally ends up in 6 meters per second in 30 seconds. So here we have to find the acceleration. So the change in velocity will be 6 minus 0, which is final velocity, minus initial velocity, divided by 30 seconds. 6 by 30, which is 0.2 meters per second, right? This is the acceleration. For the second case, the cycle slows down from 6 meters per second to 4 meters per second, right? He initially speeded up from 0 meters per second to 6 meters per second, and then he slowed down from 6 meters per second to 4 meters per second. So for slowing down from 6 meters per second to 4 meters per second, initial speed is 6 meters per second, but final speed is 4 meters per second, and this has occurred in 5 seconds. Let's check the acceleration. So you can see final speed minus initial speed, which is 4 minus 6 divided by 5. 4 minus 6 divided by 5 comes out to be 0.4 meters per second. But in this case, the answer will come out with a negative sign, right? It will come out with a negative sign. This answer will be negative. Okay, let's write the negative sign above. This answer will come out to be a negative answer. And why is this so? Why is this so? Because we are slowing down and our final speed is less than the initial speed. If the final speed is less than the initial speed, final speed minus initial speed will be a negative number. So here we get 4 minus 6 divided by 5 as minus 0.4 meter per second. So you can see here positive acceleration means speeding up, negative acceleration means slowing down, and you can also try and find out that zero acceleration means uniform motion, or the speed does not change, because the initial velocity and the final velocity will be the same to give the answer as zero acceleration. So zero acceleration means uniform motion, and any other value of acceleration means non-uniform motion, either speeding up or slowing down. So in this class we learnt about different types of motion, right? And then we measured the rate of motion, we talked about speed, we talked about velocity, and then we talked about the rate of change of velocity, which is acceleration, and how do we use its formulas in questions, right? And also, for better understanding of these topics, you can always log into webcoach.in, and you must also follow your school textbooks and the NCERT books, and you can also go for other books for further practice like the TMH group science book, right?